So good afternoon, students. Today we'll discuss about grinding process, right? So grinding is a process wherein we use a tool which is a multi-point cutting tool, right? And the grinding is different from other multi-point cutting tool processes or other machining processes, wherein the tool has no perfect geometry. Okay, so it may happen that the tool, or what I'm talking about, the abrasive grains, they are bonded to a wheel which rotates, and when that wheel comes in contact with the workpiece, the material is removed from the workpiece. Okay, so I have already shared a PowerPoint presentation with you. Okay, you can go through that. Now, uh, the grinding is the most common form of abrasive machining process. Okay, so normally when we need to remove some material from the surface of the workpiece, we need to go ahead with the grinding process, right? So the grains or the abrasive tool that I am talking about, this material is known as grit, and this grit uh, are characterized by the different things like uh, they are they have sharp cutting points, they are highly uh, hard, they are hard even at very high temperature. Okay, hot hard, so they have chemical stability, they do not react with the other materials. Okay, and uh, they are also wear resistant. Okay, because if the grinding abrasive grains, okay, they wear out, what will happen, the grinding will or the tool will wear out faster than the workpiece. Okay, however, we see for if we use the grinding wheel for a long duration, the size of the grinding wheel becomes shorter. Okay, the reason is because the bonding material uh, is unable to keep the grits together. Okay, so they detach with each other and the wheel becomes smaller in size, right? Now, in case the grinding wheel, the periphery of the wheel is not proper, so what we need to do is we need to remove some material from the periphery, okay, so that we can get a circular cross section. That process is known as truing process. Okay, right. So here we can see that there are some grinding uh, material like the grits are available here. Okay, so these are the grits. Okay, these are the grits, or we can say that cutting edges or cutting tools which are bonded with the wheel. Okay, with some suitable bonding material and to give the form of a wheel. Okay, and uh, the entire grinding wheel acts as an abrasive tool, right? Now, the major advantage and applications of grinding are like the advantages are dimensional accuracy. We get very good dimensional accuracy, we get good surface finish, we get good form and locational accuracy, right? Like suppose I want to grind at a specific space, I can do that. We can apply the grinding process to both hardened and unhardened material, right? So applications of this grinding process is surface finishing. We can finish the surface of the material. We can use it for slitting. Suppose we have a we have a long cylindrical uh, rod and we need to slit it or make a slot in that. cylindrical rod, or maybe any kind of shaft. We can do it with the grinding process. We can also part it into two parts. We can cut it from the from any portion, and we can make it into two parts. Descaling. Descaling is again any kind of scale formation is there. Okay. So any kind of like uh, accumulation of oxides or rust, we can remove it. Any kind of bar formation that has taken place due to any kind of mechanical working process, that can be removed. Any grinding process which resulted in budding, so that again can be removed. Stock removal. Stock means the material removal, that is called abrasive milling. So we normally use for finishing purposes, stock removal. Okay. And finishing of flat as well as cylindrical surface. So grinding of tools and cutters, very important for us to know, because since in this subject we have read about different type of cutting tools, their geometry. So in case the cutting tool has lost its shape and geometry, we can get it back using the grinding process. And also you have studied in tool life, the tool life is the duration of the function or duration through which the tool uh, functions between two successive grinding. That means you get the shank, you grind it properly according to the given nomenclature or given tool angles. And in case during its run the tool loses its geometry, then what happens? We need to re-grind it again. Okay, so resharpening and regrinding of tools are very important application for grinding process. Now let us come to uh, uh, comparison between grinding and abrasive machining. In grinding, the material removal rate, we can say in like material removal rate is lower, okay, than that of abrasive machining. In case of abrasive machining, the material removal rate is higher, or we can say much more material is removed in case of abrasive machining than in case of grinding. So basically grinding, we can say it is basically for your finishing purposes, or removal of very less amount of material from the from the workpiece. Okay. Next is grinding wheel and the workpiece interaction. Now the bulk grinding wheel workpiece interaction can be divided into grit workpiece, that is formation of chip that we can see in the turning process, that the tool and the workpiece comes in contact with each other and the chip formation takes place. Next is the chip bond. Okay, chip bond is, bond means the bonding material that we are talking about, right? At times it happens that the bonding material comes in contact with the chip. Okay, the hot chip. Chip comes in contact or gets uh, interacted with the workpiece even after being removed from the workpiece. And finally the bond and the workpiece. So with the bond, when the workpiece they come in contact, there is no material removal. Okay, however the bond is removed from the grinding wheel, and that is why we see that the grinding wheel becomes smaller or shorter in size. Okay, that it wears out. It is not the grits that wear out, but the bonding material that debonds. Okay, so except the grit workpiece interaction, which is expected to produce the chip, the remaining three undesirable increases the total grinding force and the power required. So the grit workpiece, that is chip formation, that is the only desirable process. The other three things like chip bond, chip workpiece, bond workpiece, these interactions have no contribution towards the material removal. However, it increases the power consumption. Therefore, the efforts should always be to maximize the grid workpiece interaction, leading to the chip formation and minimize the risk for the best utilization of the available power. That means, as you can understand from this, that the uh, arrangement or the concentration of the grids on the bond should be much more, okay, so that the grid comes in contact with the workpiece and chip formation takes place and facilitate the material removal. Okay, so let us see this process, how this grinding wheel and workpiece interacts with each other. In the meantime, I'll request all of you to just in the chat box, you note down your roll number so that I can understand how many students are attending this session, right? Okay. Now, if we look into this grinding wheel, so this is our center of rotation or axis of rotation, and the direction of the wheel is shown. The rotation of the wheel is shown. Okay, that is the direction, and this is the workpiece that comes in contact with the grids. So, as you can see here, there is some amount of chip formation that takes place, and the grit here is the cubic boron nitride grit. Okay, so the material that we are using in the form of grit or the tool material is made up of cubic boron nitride, and this bond, this bonding material is the galvanic bond. So this bonding material is used to uh, uh, means combine all these grids together and give it a shape in the abrasive wheel, okay, or the grinding wheel rather. The direction of the workpiece is in this direction, right? So you can see the material here, the depth of cut, or the rather the material removal depth has been shown quite high, just because so that you can understand. Even the size of the grids are higher so that you can understand how the process takes place. However, this is not the exact thing that happens. This much material do not get removed. However, a very thin or a very fine layer of material is removed from the surface of the work material. Okay, and if you repeat the process, keep on repeating the process, definitely you can get a higher material removal rate. However, not rate, material removal, because this process is basically for finishing process or finishing operations. Okay, and this is not basically used for higher material removal. Okay, so that is the basic idea. Now, let us look into the just give me a quick minute. Okay. Now, in the interaction of the grit with the workpiece, in case of the single point cutting tool, we have seen that the tool can either have positive rake angle, it can either have uh, zero rake angle or negative rake angle. However, in case of a grid, we cannot specify properly the geometry of the grid. That is the exact angle for each of the grids for rake and clearance angles. Okay, so that is not defined. And even the shape of the grid is, it may not be wedge shaped in all the cases. Okay, so let us quickly see uh, the uh, importance of these angles here. So the importance of the grid shape can easily be realized because it determines the grid geometry, that is the rake and the clearance angle. They do not have a definite geometry. That is a very important factor here. And normally, in case of any kind of cutting tool that we have seen, like in case of turning tool, single point cutting tool, we have seen that we have specific geometry, and we can give a nomenclature to that geometry. We can divide into different kind of rake angles. We can section the rake surface. But here we do not have a proper rake surface or a clearance or a flank surface rather. Okay, so this rake angle, grit rake angle, it may vary from positive rake angle of 45 degree to negative rake angle of -60, right? Or maybe more, right? So we cannot say that it will have a defined tool geometry. So as you can see from the diagram, in the first diagram, we have a positive rake angle, and also there is a wedge angle of theta, and but that wedge again is not proper. It is irregular in shape, but it has a proper cutting edge. However, in the next diagram, if you see that it has a negative rake angle, so the wedge angle increases. So in this case, in both the cases, if you see, the formation of the chip is not same. So in case of grinding, we cannot say that for a given tool workpiece combination, we will have a fixed combination or a fixed type of uh, chip that will be generated, whether it will be continuous, discontinuous. Normally, we see in case of grinding, discontinuous chips are formed. Okay, and normally it is not in the form of a chip, but in the form of very minute dust particles, or we can say metal particles. Okay, that comes out in the form of spark. Okay, and from the workpiece material. Grit with favorable geometry can produce chip in shear mode. Okay, as we know that if we consider grit having a favorable geometry, that is a proper cutting edge or a proper wedge shape, in that case, we can consider that the shear mechanism can take place and the material can be removed using the shear mechanism. However, normally the grit do not have a favorable geometry. It can be of different shapes. It can be round shape, uh, and it may also result in like rubbing action or plowing action, right? As we can see here. So if we have a favorable geometry, we can see the option that we have here. We can go for a, this is the geometry I'm talking about. So here if we consider this as your positive, negative rake angle. So even if it is having a negative rake angle, there is some amount of shearing action that is possible. However, for this case, it is having a round shape. So some plowing action takes place. So some of the material is not removed. However, it is displaced from one location, from this location to the next location. And finally, it can be a situation where there will be no material removal. However, there will be only rubbing that will be taking place, right? So these are the three situations that are possible in case of grinding. Let us now look into the effect of the grinding velocity and the rake angle of grit on the grinding force. So if the rake angle is negative, definitely we know that the grinding force or the cutting force required is higher. Okay, then compared, I mean, as compared to the positive rake angle, right? Because in case of positive rake angle, as we can see that the tool is more sharper, or it will have a cutting edge, proper cutting edge. However, negative will be more blunt kind of thing as compared to the positive rake angle. So definitely higher cutting force will be required for negative rake angle than that of the positive rake angle. Right. Now, here, if you look into this graph, it shows that at low grinding velocity, the difference in the grinding force, if you're considering the low grinding velocity is low, in that case, the difference is higher. However, if you increase the grinding velocity, the difference becomes less. Okay, right. So normally, grinding is carried out with at a very high velocity, because the grinding wheel is a mixture of negative as well as positive rake angles. So in order to eliminate the influence of the negative rake angle, that is the eliminate the uh, cause of the power consumption, that is the negative break angle of the material, what happens? We have to increase the cutting velocity. Okay, so that is why grinding is performed at a higher cutting velocity or higher velocity. Now let us come to the grinding machines. Okay, so these grinding machines are also regarded as machine tools. So a distinguishing feature of the grinding machines is the rotating abrasive tool. Okay, the grinding machine is employed to obtain high accuracy along with very high class of surface finish on the workpiece. Okay. However, the advent of new generation of grinding wheels, the grinding machines are characterized by their uh, rigidity, power, speed enables one to go for higher efficiency, deep grinding. Okay, we can also call it abrasive milling, right? Deep grinding means the material removal is much more. So definitely it results in milling operation, or we can say it's a substitute of the milling operation using some abrasive materials. We can also call it abrasive milling. Okay, and it can be performed not only on hardened material but also on ductile materials. Now, conventional grinding machines are of these types, that is surface grinding machine, cylindrical grinding machine, internal grinding machine, tool and cutter grinding machine. We'll discuss each of these in detail. So, surface grinding machine, this machine may be similar to the machine, milling machine used mainly to grind flat surfaces. Okay. However, some types of surface grinders are also capable of producing contour surface with formed grinding wheel. Basically, there are four different types of surface grinding machines. We can categorize it as a horizontal spindle and reciprocating table, vertical spindle and reciprocating table, horizontal spindle and rotary table, and vertical spindle and rotary table. As from the nomenclature, we can understand that the spindle rotation in the first case is horizontal, the axis is horizontal, and the table reciprocates. So let us quickly see how it is. So we can see the axis here is a horizontal axis, and the rotation is a horizontal axis, and the rotation, or we can say the reciprocation of the table takes place. So this is the workpiece, and the workpiece reciprocates, and the surface is comes in contact with the grinding wheel, and material is removed from the surface. Okay, so this is what happens in case of a horizontal spindle and reciprocating table. So the this one is the rotation of the grinding wheel. So next is the reciprocation of the work table. We can also give a transverse feed, and we can give a down feed to the grinding wheel. So a disc type grinding wheel performs the grinding action with its peripheral surface. So we can say the periphery is used here for the grinding operation. So we can have both traverse and plunge grinding. Now, what is this traverse and plunge grinding? Plunge grinding means the means the tool or the grinding wheel uh, gets inside the workpiece, okay, or enters the workpiece. As in, if I suppose this is the workpiece and we have this grinding wheel in place, or what I'll do is I'll better show a cross section of it. So this is the grinding wheel, for example. So if the grinding wheel enters the workpiece, okay, so that is called plunge grinding. Okay, however, if it is just on the surface, and normally I'll again draw it for you. So suppose this is your grinding wheel, and the workpiece which I'm talking about, suppose this is the workpiece. Okay, so if the motion of the workpiece is given rather than the grinding wheel is fixed, then this is called the traverse feed. Okay, and or plunge grinding is this one. Okay, this is the plunge grinding, right? So I believe now it is clear what is plunge grinding and what is traverse grinding. Okay, so in like both the cases can be done, or both the situations can take place in case of this horizontal spindle and reciprocating table. Next, surface grinding, that is what I was talking about. See, plunge grinding and traverse grinding. So traverse grinding is when the workpiece moves in this direction. Okay, that is, this kind of situation happens. So as the grinding wheel gets inside and the workpiece is moved, so the entire surface is removed. However, in case of plunge grinding, this is a situation only the grinding wheel moves towards the workpiece, and there is no movement in the workpiece. Okay, as such. So in the first case, if we see in the case of the traverse grinding, the rotation of the grinding wheel takes place here, and the reciprocation of the work table is there. So the entire surface is traversing, and the entire surface is experiencing a material removal. However, in case of the plunge grinding case, there is only there is only down feed of the workpiece, and definitely there is no traverse feed. Okay, in case of the plunge grinding. However, like for plunge grinding, we can say some slots. If you want to make, you can make slots using this plunge grinding process. Vertical spindle reciprocating table. Okay, now this grinding operation is similar to that of the face milling on the vertical milling machine. So in this machine, a cup-shaped wheel grinds the workpiece over its full weight using the end face of the wheel. This brings more grits in action, and at the same time, consequently, a higher material removal rate may be attained than for grinding with peripheral wheel. Right. This is what you just look into the picture and try to understand the process. Okay. So as you see in the diagram, the spindle rotation or the axis of the spindle is vertical, and the rotation or the contact is on the face, and it's not on the periphery. Contact of the grinding wheel with the workpiece is on the face and not on the periphery of the grinding wheel. So there is the rotation of the grinding wheel, and the face of the grinding wheel is in contact with the workpiece here. So the reciprocating table is there, and also the down feed of the grinding wheel is possible, so that we can remove material properly. So if you see the front view of this, you will be able to understand the situation. This is the front view of the process, and this is the top view. Okay, so we will be able to understand how the grinding process takes place. So this is the rotation of the wheel, and as the wheel rotates, this table or the workpiece reciprocates, so entire material gets the material removal takes place from the entire surface. Okay, so this is the top view, you can understand. So vertical spindle reciprocating table surface grinder. So surface grinder in vertical spindle, okay, it removes more amount of material as the face comes in contact with the or the means the more number of grits comes in contact with the workpiece. Next is the horizontal spindle rotary table grinder. So in principle, the operation is same as that for the facing on the lathe. This machine has a limitation in accommodation of the workpiece, and therefore does not have any widespread use. However, by swiveling the work table, concave or convex or taper surface can be produced. Okay, so as you can see here, So the spindle is horizontal and the table rotates. Okay, so you can produce different types of surfaces, tapered surface, concave surface, or convex surface can be produced. Okay, so these kind of surfaces can be produced, and we can use the grinding operation by this. This is a special, again, a special kind of grinding table or grinding machine. Okay. Next is grinding of a tapered surface in horizontal spindle rotary table surface grinder. So if you want to grind a tapered surface, at times it becomes difficult, and also like very much skill is required. So in that case, what you can do is you can use a horizontal spindle grinder or a grinding wheel, and you can use a, rotary table surface grinder in such a manner that the orientation is in this, that this surface which we are talking about, okay, that this surface, it can come in contact, this surface can come in contact with the grinding wheel, okay, which is perpendicular to the or we can say parallel to the axis, okay, and the material will be removed from this surface. So these kind of things are possible, uh, wherein the grinding wheel removes the material from the workpiece, like different kind of workpiece means shapes can be possible here. Okay, so the rotation of the grinding wheel is this one, and the table can be rotated here at a certain angle depending on the profile of the workpiece. Okay, and again, the table can be reciprocated. The entire table can be reciprocated so that the entire surface can be the material can be removed from this entire surface, and definitely down feed also is there, and swivel angle is also there. That is the angle at which the entire table can be rotated. Okay, so cross means reciprocation as well as rotation, both are applied here in this case of in this case, right? Next is vertical spindle rotary table grinder. So the machine is mostly suitable for small workpieces in large quantities. Okay, if we have large quantities of workpieces that you want to grind, in that case you will have this vertical spindle rotary table in which grinding wheels will be there, and you just need to place your workpiece, and the workpiece will be grinded. Okay, so the primary production type machine often uses two or more grinding heads, thus enabling both roughing and finishing. So roughing definitely will have bigger size grids, and finishing will be having smaller size grids. Okay. Creep feed and high efficiency deep grinding machine. Creep feed is like the machine enables single pass grinding of the surface with a larger down feed but slower table speed than that adopted for multi-pass conventional surface grinding. This machine is characterized by high stiffness, high spindle power, recirculating ball screw drive for table movement, and adequate supply of grinding fluid. Okay. Further development in this field is a creep feed grinding center, which carries more than one wheel with provision of automatic wheel changing. A number of operations can be performed on the workpiece. It is implied that in such machines, in view of the size and complexity, are automated through CNC. Okay.